Allocation as a Flow Problem by Rainer Saint-Vilm and Aram Bagdasarian. Going into a little bit of background, Aram and I both lead organizations on campus, with Aram leading the Design and Tech Initiative, or DTI, and I leading the Underrepresented Minorities in Computing, or URMC. Within both of our organizations, we have mentorship programs where we can help to pair mentors and mentees together. Finding the correct pairings such that the maximum number of members can participate while sharing interests and availability is an important aspect and issue that we have to solve. Going into the rules for mentorship pairings, we get from each applicant these pieces of information: whether they want to be a mentor or a mentee, the times that they're free, the interests that they have, and for mentors, the bandwidth for number of mentees they can take on. We only consider making introductions if both a potential mentee and mentor are free at some time, share interests, and the mentor still has bandwidth to take on more mentees. Looking at the Ford-Fulkerson or max flow algorithm, Ford-Fulkerson is a greedy maximum flow algorithm using depth first search to find paths with capacity within the mentor and mentee graph. Our goal is to find the maximum number of introductions that we can make based off of the applicant pool. Determining the maximum flow within this graph of applicants using Ford-Fulkerson can lead us to that answer along with the pairings themselves. For a visual explanation of how Ford-Fulkerson works, we have our graph here, which has our source, our mentees, our complete time slots that mentors have, our mentors, and the sink. As we look at the source, flow will go through each of the nodes on this graph, and if this mentee can meet with this mentor at this time, we will then flow to the mentor and down to the sink. At the end, the maximum flow allowed into the sink can show the number of mentee and mentor pairings that we can possibly have, and helping us maximize the number of people who are able to pair with the mentor. After running this algorithm on data we've had available, we could see that 99 of 100 mentees could be paired. Thanks for listening, and sorry for that one student who didn't get paired.